Hello and welcome friends for this particular presentation. Here we wish to discuss about the sensitivity of the level tube, rather sensitivity of longitudinal level tube of the leveling equipment. It's better to know about the basic concepts that we have discussed in Module 2B regarding the construction of the level in general and specifically about the longitudinal level tube. Here we wish to discuss about the sensitivity definition. We wish to discuss about the factors affecting the sensitivity and the relationship between the sensitivity and the radius of the level tube, and we will also solve some problems based on the determination of this particular sensitivity of the level tube. As you go through the content, you will be able to define the sensitivity as well as state the factors affecting the sensitivity, as well as you will be able to determine the sensitivity and recognize the precision of the level used for leveling works. In general, the sensitivity is the capability of exhibiting smallest deviation of the level from the horizontality of the line of collimation. When the bubble is not much sensitive, the degree of the precision will be low. Here, I wish to have again some brief recap over the discussion that we had previously, that every surveying equipment is provided with longitudinal level tube. It is provided with certain graduations. That level tube is provided with some curvilinear aspect with its crown pointing in the upward direction. It is filled with some alcohol like thing so that the entrapment of the small bubble will help us to define the axis of bubble tube, and in turn we define the line of collimation as well as axis of telescope with respect to the axis of bubble tube. Hence, the sensitivity is an important parameter as it decides about the overall precision and accuracy of the leveling. The sensitivity of the level can be defined as the change of angle or gradient required to move the bubble through one division of longitudinal level tube. Usually, that particular one division width is of 2 millimeter. The sensitivity can be expressed as an angle which could be seconds per division, or it can also be expressed in terms of radius of the level tube. Though it is designated in terms of radius of the curvature of this particular level tube, it's always better to state it in terms of angle through which the axis of bubble tube must be tilted to cause this particular bubble to travel through this particular one division. The angular value of this particular 2 mm division, which is nothing but the sensitivity of the level tube, ranges in between 8 seconds to 45 seconds. If the sensitivity need not be greater than what really is necessity, unnecessarily we waste the time in leveling operations. So I hope you remember about the classes of leveling as ordinary leveling, rough leveling, precise leveling, etc. So whenever we are dealing with some leveling works where the accuracy is of much importance, such as say setting the network of benchmarks or transferring the requisite reduced level to some other station in order to set some say foundation or some such similar structure. So according to our requirement, we can choose the equipment to have the requisite sensitivity. So mainly this particular sensitivity depends on the radius of the curvature of the level tube. So this particular radius may vary in between 10 to 300 meters. The larger the radius, greater will be the sensitivity. The sensitivity can also be increased by increase in length of the division, diameter of the tube, length of the bubble tube, as well as here even the smoothness of inner surface. So the way I mentioned earlier, this particular level tube is filled with some alcohol like less viscous liquid which is further entrapped with some air in order to get this particular position of the bubble. So lesser the viscosity and the surface tension of this particular liquid, the level tube, greater will be the sensitivity. We can also derive the relationship between the sensitivity and radius. So let d be the width of one division, the way I have shown here. This particular pi is angle subtended by this particular one division at the center of that particular curve of the level tube. So this pi can be expressed as 2 pi by 2 pi r times d. Hence it comes to be d by r radians, as 1 radian is equal to 206.265 seconds. So accordingly here this d by r can be multiplied by 206.265 to express this particular pi in terms of seconds. For a particular case, if we consider this d to be 2 mm, which is usually prevailing value, so this r can be expressed in meters, and this particular pi can be expressed as 412.53 divided by r. By making use of this particular expression, for various radius, we can determine the sensitivity. So here if this particular radius is 41.25 meter, sensitivity comes to be 10 second. If it is 20.62, it comes to be 20 second. If it is 10.313, it comes to be 40 second. As such, whenever we go on increasing this particular radius, proportionately there will be increase in sensitivity. That is, for smallest deviation of the vertical axis, there will be larger displacement of the position of the bubble with respect to its central location. There are two methods of determination of the sensitivity. Here, for better understanding, I am considering just one method. Let's select this particular equipment setup established at A and stop situation at B. We can maintain this particular distance, say 50 to 100 meter, which can be measured accurately. So here we have to set the equipment at station A and how the temporary adjustments done, so as to how that particular bubble at the center of its run, and accordingly we can take the stop reading which is kept at station B, say if it is A. Now subsequently we can move the bubble through some end divisions, and accordingly further we can take the stop reading, say as B. So the stop intercept cost can be expressed as S and its value will be B minus A. So as we consider this particular triangle CFG, this CE is nothing but the portion of the level tube which will be very small as compared to this particular D. Hence we can consider this particular CFG to be certain approximate triangle, and here this particular tan alpha can be worked out as S by D. So having this particular alpha very small, this S by T can be considered to be alpha itself. Similarly, from approximate triangle ACE, tan alpha can be worked out by as CE by R. Here this CE is caused because of the deviation of the bubble through M number. Hence this CE will be N times D. As such, this CE by R will be equal to ND by R. As we compare this 1 and 2, radius of this particular level tube can be worked out as NDD by S. As phi is angular value of one division, this phi will be equal to alpha by n. As we substitute the value of alpha as we have determined above, accordingly it comes to be nd by r. As such, this phi can be expressed as s by nd. As 1 radian is equal to 206265 seconds, the sensitivity can be determined by this particular expression s by nd into 206265 seconds. Let's try to understand problem based on the concept that we discussed. So here with the line of sight horizontal, star reading taken is 3.55 meter. The distance is of 100 meters. As we move the bubble through this particular 5 divisions, the reading caused is 3.5 meter. We wish to determine the radius and the sensitivity of the level tube. Here, the width of the division is considered to be 2 millimeters. So, it is straightway substitution in the expressions that we have derived in our earlier slide. So, R is equal to NDD upon S, it comes to be 20 meter. Similarly, as we have the expression phi is equal to S by ND into 206265, as we substitute the values, we can determine that particular sensitivity as 20.63 seconds. It's always better to express this particular sensitivity as per division. Here, the sensitivity is given as 40 seconds per division. Now here, the bubble position is 4 divisions off. We wish to determine the error caused in the staff reading, which is held at 250 meters from the instrument. So, we can make use of same expression, phi is equal to S by ND into 206265 seconds. So, as we substitute the values here, as the sensitivity is given to be 40 seconds, S is to be determined, which will be nothing but the error caused in this particular staff reading, as the bubble is shifted through that 4 divisions, which comes to be 0.194 meters. As we have the expression for determination of R, here having known all these particular parameters, it can be simply substituted in order to work out that particular radius as 5.15 meters. So I hope the concept that we discussed about the determination of sensitivity is clear to you. In coming presentation, we'll discuss about the permanent adjustments of the level that we use in leveling operation. So by till then, I wish you very happy learning. Thank you.